Hi guys, welcome to question. Oh my god, I mess this up every time. Welcome to tutorial 3, question 1. Let's do this. As always, I'm going to put the question right over here. Pause the video, read it over, attempt it yourself, and then we'll go through it together. Alright, so we're going to start with 1A, and again, I'm going to, maybe just put just 1A over here, right here. And let's do this. So when we tend to do these questions, as you know and you've learned from the class, we got to prove the big O, and then we got to prove the big omega. And once we've proved these two, it's been proven. Alright, so we're going to start off with the big O. Alright, so square root of 7x squared plus 4x, how can we make that bigger? Meanwhile simplifying it. Alright, okay. In my opinion, the number one thing we can do is to change the 4x into a 4x squared. So the inequality would be square root of 7x squared plus 4x is smaller than or equal to square root of 7x squared plus 4x squared. For x obviously being bigger than or equal to 0. And then after that, now we have 7x squared plus 4x squared. Well, what is that? That's 11x squared. How can we, again, make this larger and at the same time simplify it? How about we say that, square root of 11x squared is smaller than or equal to square root of 16x squared. Why am I doing that? Well, because that way I can get the square root of 16 and x squared, which equals to 4x. And we've just got rid of the square root. And, I think that's pretty much what's appropriate here. I want to put it right over here. But, hopefully it's already up there. But this equals to 4x. We took it from where it was, and we brought this inequality to a point where it's 4x. So we have chosen an n naught of equaling to 0, and a c of, obviously, the coefficient being 4. Therefore, square root of 7x squared plus 4x has a big O of x, because it's 4x, so it's x. So yeah. Now let's do the let's attempt big omega. I keep forgetting these words while I do the video. I kind of get nervous. Alright, so same thing goes here, but this time it's backwards. We got to make it the inequality to become smaller and smaller to the point where we feel like it's appropriate. Alright, so square root of 7x squared plus 4x. How can we make this smaller? Okay, well, we can say that square root of 7x squared plus 4x is bigger than or equal to, square root of 7x squared. Get rid of the plus 4x. And remember, it's for x being bigger than or equal to 0, right? And, alright, okay, so it's square root of 7x squared in our inequality. The next step would be how can we get rid of that square root, similar to what we did in the big O step? Well, how about we bring it from the 7x squared to 4x squared? That way, it's going to be square root of 4x squared, and then, 4 with the square root goes away, and x squared with the square root becomes an x, and, we bring this inequality to equal to 2x. So we went from square root of 7x squared plus 4x all the way to 2x. And we've chosen an n naught of 0 and coefficient and c of 2. So therefore, the big omega of this function, square root of 7x squared plus 4x, is big omega of x. And since we've proven the big O and the big omega of this function, we know that this function holds. So that's it. That's our solution for exercise 1A. Alright, now we're gonna try to attack 1B, and it says prove that round bracket. I want to put it here anyway, so you can see it. But sorry if I missay it. But round bracket square root of 2 to the power, all of that to the power of log n is equal to big theta of square root of n. Basically trying to get its runtime. And just as a reminder, the base of 2 is the default base of log in this course. We've actually said it even in the welcome video, I think. But yeah, keep that in mind. And with that in mind, let's go for it. So in order to prove this, my hack is a little cheeky for this question, but you'll see what I mean. In this question, I'm not going to attempt to do big O first and then big omega. You can do that for sure. There's nothing wrong with it. If you prove both ends, good to go. But I want to try two birds, one stone, because I'm lazy, I'll be honest with you. I look at this formula, square root of 2 to the power of log n. And, I'm going to apply a cheeky mathematical algebra, magic shindig that I'm going to, make my life easier. Square root of 2, all of that to the power of log of n. Well, there is this identity, which I'm going to put right here. That's my magic sound. Sorry, I know, it's lame. But where, as you can see up here, we say that a to the power of log of base b, c, equals to, we just flipped the a and the c. And that's the case here. We just flipped the square root of 2 with the n that was in the exponent of the original function. So now we have n to the power of log of square root of 2. Okay, so the question becomes, all right, what is square root of 2? Okay, dumb question, but I'm trying to get to a point. Square root of 2 is 2 to the power of 1 over 2, right? We all know that. Okay, but since this 2 to the power of 1 over 2 is in the log, we can just simply bring it out. So it becomes n to the power of 1 over 2 times the log of 2. But then let's not forget something. Remember the assumption we made. The log in default in this course is going to be a log of base 2. So log of base 2 of 2 is what? 1. So that cancels out. So all we have left is n to the power of 1 over 2. In other words, it's square root of n. Now, some of you might be asking, like, okay, so what, right? How is this a, cheeky cheat? Or why didn't you just get the big O and the big omega? Well, think about it. I never use an inequality here. I just used equal signs. I just went down the, mathematical switches. And, since there are no inequalities anywhere, we've proved big omega and big O at the same time. I know. You might think it's not possible, but we did it. And if you go over it, there is nothing wrong with doing them together. And c can be set to 1, and the n naught can be any value. And that's it. That's all there is for this question. But again, remember, you can do it the other way, but if you find it, like me, a little lazy to do it like this, you can also do that. And that is all for, question 1. I'll see you guys in the next one.